Hello, we are going to discuss magnetism and matter. We are discussing the basics of magnet. Here, Earth behaves like a huge magnet. So, freely suspended magnet always pointing in particular direction, that is magnetic south or geographical north, is called magnetic meridian. Means freely suspended magnet always stay in particular direction, that is magnetic meridian. Geographical meridian and magnetic meridians are not coinciding, but there is an angular gap between them. It is called say magnetic declination. It is varying from place to place, time to time, 0 to 18 degree. Every magnet attracts magnetic material like iron, nickel, cobalt towards it. Maximum attraction at the ends. These are called poles of equal strength, North Pole and South Pole. Like poles, north-north and south-south, they repel, and opposite poles they attract each other. Repulsion is a sure test of magnetism, not attraction, because magnet attracts even unmagnetized magnetic material. Force of attraction or repulsion between the two magnetic poles of pole strength, say M1, M2, their separated distance R. This force is given by F equal to K, proportionality constant K, and M1 M2 upon R square. M1 M2 are the pole strengths, not the masses. K is called proportionality constant, is mu naught upon 4 pi. Numerical value here is 10 to the power minus 7, and K is 1 for CJ system, 10 to the power minus 7 for MKS system. Now this is the Coulombian force in magnetism. Magnetic poles always exist in pair. So monopole does not exist. It is always in pair. So monopole is not possible. Now, properties of magnetic lines of force. Magnetic field lines of force of a magnet form closed path, closed continuous loop, whereas electrical field is not possible. They are not never forming the closed loop. Outside the body of a magnet, direction of field lines from North Pole, South Pole, where it's inside, south to North Pole. Lines of force, they never intersect each other, just like electrical lines of force also not intersecting. Similarly, magnetic lines of force also never intersecting each other. Tangent at the point gives the direction of magnetic field. So magnetic field is the flux per unit area. That is why it is called sometimes flux density. So magnetic field also defined as flux per unit area, flux density. Now current loop as a magnetic dipole. Suppose here this is a loop, direction of current in anti-clockwise direction, let it is making the magnet behaving like a magnet. So here upper pole anti-clockwise, so upper pole, clockwise, so the south pole, this is the north pole. And M is the dipole moment always from acting say south pole to north pole. Here this direction of dipole moment M is from south to north, so upward direction. This is the normal unit vector of area cross section. So here M is directed from south to north upward. M is directly proportional to strength of the current and area of cross section. Simultaneously, M is directly proportional to IA is proportionality constant 1. If number of turns in the coil N, so it will be multiplied with N, NIA. Magnitude of dipole moment is NIA, where here is this the vector form. So area vector is here south to north, so upward. Direction of M is here south to north. A very important topic here. Bar magnet behaves like an equivalent solenoid. So here bar magnet and equivalent solenoid, they are behaving like same. So let us say this is the bar magnet. We can consider here their current loops. Solenoid can be taken as a large number of circulating current loops with a bar magnet. Let us, this is the elemental portion of thickness dx. Current is flowing here. I from the center. This is at a distance of x. The total length of this solenoid or bar magnet is 12. We are interested to find out the magnetic field at point P at a distance of r from the center. So OP distance equal to r. Now due to the elemental portion, magnetic field is given by formula at the axis. So this is the formula of magnetic field, small magnetic field due to the current element here given by this axial point का formula है. Unit I, A is the radius here, and n dx is the number of turns, and distance here say this is r minus x from this current loop. This is the distance up to the point P, r minus x. So using the formula here, dB given by this equation, r is very large than a, r is very large than x also. हमने इसको नेग्लेक्ट कर दिया, x को और a को नेग्लेक्ट करके ये मिल जाएगा dB. So if we integrate here, limit is say from minus L plus L, considering the total bar magnet of length 12. So minus L to plus L, this is the limit. Now is taken out, dx limit is minus L to plus L. So this is x minus L to plus, so 12. Upper limit minus lower limit, minus plus हो जाए. So हम ऐसे भी लिख सकते हैं. This is 2n into 2l. We are integrating, limit here is for the whole solenoid in minus L to plus L. ये बाहर आ गया लिमिट माइनस एल टू प्लस एल, dx का इंटीग्रेशन x, लोअर लिमिट माइनस एल, अपर लिमिट 2l, so 12. हमने स्मॉल n है नंबर ऑफ टर्न्स पर यूनिट लेंथ मल्टीप्लाइड बाय द लेंथ इज द टोटल नंबर ऑफ टर्न्स. तो के लिए हमने लिखा NIA इज m, कैपिटल M इज द डाइपोल मोमेंट. NIA की जगह हमने m लिख दिया. ये फॉर्मूला मैग्नेटिक फील्ड का हो गया फाइनली, म्यू नॉट अपॉन 4 पाई 2m अपॉन r क्यूब. Gauss line magnetism in closed path. If magnet is placed here in between, so south pole, north pole, they are cancelled out. So there's no, you can say here, effectively magnetic field is zero. Region here is at the close, south pole, north pole दोनों हैं. So lines of force are coming out due to north and going into the due to the south pole. So effectively there's no magnetic field. So this is the Gauss law for the closed path. Effective flux, total flux, net flux will be zero. Unit of magnetic flux is Weber or Tesla meter square. Now again, important topic here is the Bohr magnetron. Bohr magnetron. Let us consider this electron is revolving around the nucleus. So equivalently current in the opposite direction, and current loop behaves like a magnet. So here dipole moment is given by I into A. I is the current, A is the area of cross section, pi r square. So current is given by charge divided by time period. टाइम पीरियड t इज इक्वल टू 2 पाई बाई ओमेगा. ये ओमेगा पर चला जाएगा. सो m विल बी हाफ e ओमेगा r स्क्वायर given by equation 1. Now as per the Bohr's theory, second postulate, angular momentum L is mvr equal to nh upon 2 pi and must be integer and v is equal to r omega. ये हमने v की जगह r omega लिख दिया. m ओमेगा आर एन आर स्क्वायर हो गया, एन एच अपॉन 2 पाई. ओमेगा आर स्क्वायर की वैल्यू हमको नीचे ले जाएंगे, ये हो जाएगी गिवन बाय इक्वेशन 2. ओमेगा आर स्क्वायर तो यूज कर रहे हैं हम इक्वेशन 1 में. तो पुटिंग द वैल्यू ऑफ ओमेगा आर स्क्वायर फ्रॉम इक्वेशन 2, पुटिंग इन इक्वेशन 1, we get m equal to this 1 by 2e and omega r square की ये वैल्यू हो गई. तो हमने EH अपॉन 4 पाई m लिख दिया. एंड इस क्वांटिटी को बोल रहे हैं बोर मैग्नेट्रॉन B. अगर न्यूमेरिकल वैल्यू निकालनी हो म्यू बी की, तो बोर मैग्नेट्रॉन E, इलेक्ट्रॉन का चार्ज 1.6 × 10⁻19, H प्लैंक कांस्टेंट 6.63 × 10⁻34, 4 पाई वैल्यू 3.414. M is the mass of electron 9.1 × 10⁻27. After solving, we are getting this value of Bohr magnetron is 9.24 × 10⁻24 ampere meter square. Gyromagnetic ratio of electron is defined as the magnetic dipole moment divided by angular momentum. दोनों का फॉर्मूला मालूम है मैग्नेटिक डाइपोल का 1/2 ओमेगा r स्क्वायर एंड एंगुलर मोमेंटम mr ओमेगा स्क्वायर कैंसिल होके E/2m. ये इलेक्ट्रॉन का चार्ज m इज द मास ऑफ इलेक्ट्रॉन पुट करके आंसर आ रहा है 8.8 into 10 कूलम पर kg. Now there are some important terms here in magnetism. First is say magnetic permeability. This is the property of a magnetic material medium. It is the ability of a material to permit to allow the passage of magnetic lines of force passing it. Relative permeability is defined as the ratio of magnetic field strength vacuum and ratio of magnetic field strength in medium to magnetic field in vacuum. So magnetic field in medium upon magnetic field in vacuum ये सेम रेशियो मिलेगा m permeability of the medium upon permeability of the vacuum h and I cancel हो जाएगा. So this is the ratio. Either you can write the magnetic field in magnetic medium material upon magnetic field in vacuum or upon relative permeability of the medium upon relative permeability of the vacuum. So this is the relative permeability is given as permeability of the medium upon permeability of the vacuum. Magnetic field strength, magnetic field strength B of a magnetic field induction, or it is called sometimes flux density, is equal to the force experienced by a unit positive charge moving with velocity v, direction perpendicular to the magnetic field. Now magnetizing force H equal to Ni. It depends on number of turns current length multiplied by the I. It is defined as the number of ampere turns flowing around the unit length of the solenoid produce the magnetic field induction. Formula B naught vacuum में mu naught Ni, so this is mu naught H, means H is equal to Ni. SI unit of H is ampere per meter, CGS unit is Oster. Intensity of magnetization, it is defined as the magnetic moment per unit volume of the material in the magnetizing field. So I, intensity of magnetization is magnetic moment upon volume, m upon V. Capital M dipole moment can be written as m into 2L. M is the pole strength, 2L is the length. Volume is area into length. 12 cancel, okay, M upon A. M means pole strength upon A is the area of cross section. So intensity of magnetization can be defined as the pole strength per unit area of cross section also, or magnetic dipole moment per unit volume. SI unit here is here per meter. Now magnetic susceptibility chi m, इसे हम प्रोनाउंस करते हैं chi से. So magnetic susceptibility chi m, it is defined as the ratio of intensity of magnetization I to the magnetizing force. So this is the formula here for magnetic susceptibility I of H. It is unitless, dimensionless. We have to derive the relation between mu r and chi, is also important here. Suppose we have taken a solenoid and inside we have inserted the magnetic material like soft iron. When a magnetic material is placed here, a magnetizing field of intensity H, the magnetic material gets magnetized. Total magnetic induction is given as V naught, means the magnetic field inside the solenoid when there is no magnetic material, means in vacuum, and Bm is the magnetic field in the material. Total magnetic field will be the addition of these two. In vacuum mu naught H, and this is the magnetic field in magnetic material mu naught I. I is the intensity of magnetization. Now mu की जगह हम लोग लिख रहे हैं mu r, डेफिनेशन से mu upon mu naught, तो mu will be mu r divided by mu naught, पुट कर दिया. तो here if we divide mu naught कैंसिल हो गया, h से भी डिवाइड किया, mu naught h कैंसिल होके 1 आ गया, यहाँ पे mu naught कैंसिल. mu r is equal to 1 plus I upon h को हम बोल रहे हैं chi. So this is the relation derived, the relation between the relative permeability and the magnetic susceptibility. Mu r is equal to 1 plus chi m. Now here is a classification of magnetic material. Properties: the paramagnetic material, this is the diamagnetic material, this is the ferromagnetic material. When it is placed in uniform magnetic field, Ghibli means very small magnetization is there along the applied field, because it is supporting paramagnetic material is supporting the external magnetic field, but very less support. But here in diamagnetic material there is opposition, and in ferromagnetic strongly magnetized along the magnetic field direction. ये प्रॉपर्टीज होंगी पैरामैग्नेटिक, तो बहुत ज़्यादा लार्ज अमाउंट में कर दें सारी प्रॉपर्टीज को एनहेंस कर दें तो ये फेरोमैग्नेटिक की प्रॉपर्टीज बन जाए. ससेप्टिबिलिटी, इट इज वेरी स्मॉल बट पॉजिटिव, इट इज वेरी स्मॉल बट नेगेटिव, दैट इज वाई feebly very less opposition is there, and it is very large. Roughly for soft iron, susceptibility is roughly more than 1000 times magnetized. Relative permeability, it's 1 and 2 के बीच में है. ये रिलेशन से मालूम हमको कि 1 प्लस m इज इक्वल टू व्हाट, काई में अगर हम लोग 1 ऐड करते हैं तो ये रिलेटिव परमेबिलिटी बन जाएगा. इसलिए 1 एंड के बीच, यहाँ 0 1 के बीच में, ये 1 and 2 के पॉजिटिव एंड लेस देन 1, वेरी लार्ज. This effect of temperature in paramagnetic material is inversely proportional to temperature. Diamagnetic is independent of temperature, and for ferromagnetic material is given by this. T is the temperature, T is the critical temperature, or sometimes it is called Curie temperature. Discuss Curie temperature, Curie law. Relation between I and H is linearly change. Linear change for it is saturable at low temperature. Temperature पर ज़्यादा डिपेंड करता ही नहीं. नॉन लीनियर चेंज. मैग्नेटिक डाइपोल नॉन जीरो इज जीरो, इज नॉन जीरो मैग्नेटिक का डाइपोल मोमेंट जीरो, कैंसिल हो जा रहा है. फील्ड लाइन विल बी, अगर हमने इसे मैग्नेटिक मटेरियल में पैरामैग्नेटिक मटेरियल रखेंगे तो सम लाइंस ऑफ फोर्स आर पासिंग थ्रू द मैग्नेटिक मटेरियल, पैरामैग्नेटिक मटेरियल, एंड जो बहुत दूर है उनको अपने तरफ अट्रैक्ट नहीं कर पा रहा है. एंड डायमैग्नेटिक दे आर रिपेलिंग लाइंस ऑफ फोर्स, तो इसके अंदर से पास ही नहीं हो रही. Whereas बहुत ज्यादा नंबर ऑफ लाइंस ऑफ फोर्स, almost all the lines of force passing through the magnetic material is the ferromagnetic material, and these are the examples of paramagnetic, diamagnetic and ferromagnetic. At least 2-3 examples सबके को याद होने. For paramagnetic, for diamagnetic and for ferromagnetic, at least 2-3 एग्जाम में आते हैं बोर्ड में, थोड़े एग्जाम के लिए आपको याद रखना. नाउ Curie law. According to Curie law, intensity of magnetization is directly proportional to the magnetic field induction and inversely proportional to temperature. So I, intensity of magnetization is directly proportional to B, inversely proportional, and B and H directly proportional to H by T भी लिख सकते. So here I को हमने ये इधर H डिवाइड कर दिया. I upon H is inversely proportional to 1 by T. एक कांस्टेंट लगा देंगे यहाँ पे, हम बोलेंगे काई. रेशियो ऑफ I upon H को काई, तो काई डायरेक्टली प्रोपोर्शनल टू 1 by T. constant लगा दिया C called Curie tent. A Curie temperature is the temperature at which a ferromagnetic material completely changes and behaves like a paramagnetic material. So ordinary magnetic field is there. This temperature is called Curie temperature. For iron, it is more than 1000 Kelvin, and at this temperature or above the temperature, this ferromagnetism is lost and behaves like ordinary paramagnetic material. Now discussing the hysteresis curve, or sometimes it's called BH curve. B और H में curve है, so BH curve or hysteresis. The phenomena of lagging of magnetic field or high intensity magnetization behind H when a specimen of ferromagnetic material is placed in the external magnetic field and there is a change of cycle. If suppose due to the external magnetic field it is magnetized and this will be like this. अगर इसकी H को हम कम करेंगे तो ये B भी कम होगा, बट H जीरो करने के बाद भी B जीरो नहीं हो रहा. It means some dipoles are aligned still and this is a retaining power, sometimes it is called retentivity or residual मैग्नेटिज्म. और इसको हम अपोजिट डायरेक्शन में मैग्नेटाइज करेंगे तब जाके ये मैग्नेटिक फील्ड जीरो का. सिमिलरली फॉर दिस साइकिल, ये हॉरिजॉन्टल पार्ट जितना मैग्नेटिक फील्ड देने से अपोजिट डायरेक्शन में जीरो हो रहा है मैग्नेटिक फील्ड, तो बोलेंगे हम कॉर्सिविटी. H को जीरो करने से जितना मैग्नेटिक फील्ड रह गया रिटेनिंग, दैट इज कॉल्ड रिटेंटिविटी. So what is the retentivity? It is the value of magnetic action left in the ferromagnetic material when the magnetized force reduces to जीरो, इसका रिटेंटिविटी एंड रेजिडुअल मैग्नेटिज्म। और इसको बोलेंगे कोर्सिविटी, amount of magnetizing force required to in opposite direction to reduce the residual magnetism to zero. This is called coercivity. एक वन साइकिल में जितनी एनर्जी लॉस हो रही है, the amount of energy lost in magnetizing and demagnetising in one cycle. एक साइकिल में मैग्नेटाइज डीमैग्नेटाइज करने में जो एनर्जी लॉस है, that is the energy loss in one cycle. It is given by the area of this CH curve. ये स्टैंडर्ड पोर्शन जो दिखा है, this is the area. It will give you the energy lost in one cycle to magnetize and demagnetize, to magnetize and demagnetize in opposite direction also. In one cycle, the area of this curve is when has the energy loss. For permanent magnet, permeability should be very high, retentivity should be high, and coercivity is also high for permanent magnet. जल्दी से डीमैग्नेटाइज नहीं हो. एग्जांपल्स आर स्टील, आयरन, एल्निको. तो बहुत जल्दी से मैग्नेटाइज कर सकते हैं परमानेंटली. फॉर इलेक्ट्रोमैग्नेट, परमेबिलिटी शुड बी हाई, but retentivity must be low and coercivity should be low. अगर retentivity ज़्यादा है तो बहुत अच्छी बात. एग्जाम्पल हियर इज सॉफ्ट आयरन. इट इज कॉल्ड टेम्परेरी मैग्नेट.